And yes, I know people hate to think, but that's what they want you to do. So, here are some things your teachers are going to expect you to remember. The accelerations. How much is the acceleration in the x direction? 0. What about y? -10. That brings up something. This is going down 100 meters. The acceleration is downwards. Both of these should be negative, or you can have them both positive. Just pick a direction to be positive or negative, and make sure these two agree. Okay. Well, if the acceleration is 0 in x, what does that mean the final velocity is? In x.
The same as initial.
It's the same. It's a constant. Good job. Okay. If I'm rolling off this cliff, how fast do I start moving in y? 0. I'm not moving in y, then I start to fall. So I have to start at 0. And all of this in green are things your teachers will expect you guys to figure out on your own without being told of the problem. Now, some of them might write it down as the problem, but the stuff in green are things they would expect you to figure out. Okay? If you are comfortable with this, just do a bunch of practice problems at home, or you don't. You probably don't live at your home couch. But I digress. If you have more questions about what this, we can talk separately afterwards. Okay. So now, what are we trying to find? Time. We're looking for how far from the cliff. We're looking for how far this guy goes. X, I heard someone say dx. Same thing. Okay. So if we were going to find the distance, how should we go about this? Blue one? Okay. Distance equals BI t plus 1/2 kt squared. Okay? So we look at what we know. Distance is what we're looking for. Good. We know the initial velocity. We know the acceleration. Do we know the time? No. We need to find time first. How can we go about finding time? Yes?
Green.
Green. Okay. So, will we use the x coordinates to find time or y? We will need to use y. So we do need to use the y coordinates to find time. So in a cliff problem, you will use y to find time. However, we can't use green because we don't know VF. We can, however, go back to blue to find time in the y direction. Finding time. Use y. Distance, VI t plus 1/2 kt squared. Says we're using y, which part of this goes away? Yeah, initial velocity 0. 0 times time is 0. So distance, negative 100 equals 0 plus 1/2. Acceleration, negative 10 times squared. This leaves us with negative 100 meals equals negative 5 meals per second squared times squared. Divide by negative 5. And you get 20 seconds squared equals time squared. Square root. And how long does it take this ball to fall?
Uh, 4.47 seconds.
4.47 seconds. Actually, let me put that. Okay? While none of these other variables will, all of these variables can be different in x and y. Time is always the same. So now that we know time, we can go back to this equation. Distance equals VI, 10, times time, 4.47, plus 1/2 times 0 meals per second squared, times squared. This cancels out. We get distance is equal to 10 meals per second times 4.47 seconds, and we get 45 about meters. Okay, so the teacher could also ask you for what the final velocity is in y. In that case, you would use this equation. Final velocity equals the initial velocity plus 2 times how far you fall times your acceleration. But if you're asked the distance in x, first you will need to use y to solve for time. Okay? Yes?
Can you use the red equation and use all the stuff you have already?
Yes, there's more than one way to tackle each problem.
Okay.
The main thing is that you know, depending on what you know. We couldn't use red to find distance with x, however, because the acceleration was 0. So this part goes away and we get 10 squared equals 10 squared. I didn't know which part you were referring to, but if you were referring to x distance. Okay? But yes, there's more than one way to solve each of these problems. Okay? And that was probably your first month of class. Now, let's get to Isaac Newton. Unless anyone has specific questions. No? Okay. It's just one quick fact I could tell you guys. Are any of you in Calculus 1 or have taken Calc 1? Yes? This second equation in green is the derivative of the equation in blue. The derivative of position is velocity if you take it with respect to time. So that's something you could use to remember the equations. But for the rest of you, you don't need to know that. Forces. So, this is when you guys probably got into Isaac Newton's laws of motion. Let's just make sure that's still on. Yep. Isaac Newton had 3 laws. And you probably all have heard them before, even before you took physics. Object at rest stays at rest. Object in motion. Yep. That means your acceleration is always 0 most of the time. Standing here. Nothing's pushing me. Am I going to randomly start moving without push? No. This chair is going to stay a chair. It's not going to move until someone like me decides to make it move. Same thing, the Earth is moving around the sun. It's not just going to decide to stop one day. If it did, you'll have some problems. But, so that means, what do you need to do to make something move? You need to apply a force. A force, defined by Isaac Newton, is just the object's mass times its acceleration. So if I want to start moving, I need a push. Specifically, I push my leg against the ground, and that causes me to move. There's a force there, I accelerate. It's not moving, I push this guy, it can accelerate to speed up. But, my example before of pushing on the ground to make myself move, you might be thinking, well, you're pushing on the ground, but what's pushing you? The third law. Every action is equal and opposite reaction. So I push on the ground pushes back at me, that's why you can move. If I hit the wall, I can feel a force on my hand, it can hold. That's because when I apply a force to the wall applies a force against me, and it stops my hand from moving. It decelerates me. So that's Newton's laws in a nutshell. So in your class, there's several forces you probably talk about. The force of gravity. That's just how gravity pulls on objects. Force of gravity is equal to the object's mass times the acceleration due to gravity. Looks very similar to this equation, but instead of using A, we use G, which is the specific acceleration due to gravity. I'll come back to that. Friction, that's how you slow stuff down. I might have this rolling on the ground, but eventually it stops. That's how brakes work. You stop the wheels from moving on a bike and you eventually skid to a stop. Well, you slow down the wheels with friction inside, you don't just skid to a stop. But that's the idea. But before I get to the equation of that, you'll need another equation. Gravity's pulling on this. I let it go, it starts falling. Is gravity still pulling on it? Yeah. It's not flying off the earth, there's still gravity. Then why did it stop moving? Table. The table is applying what type of force? You should just think of where you're living right now. It's a normal force. A normal force is a force that comes from the ground or a surface and pushes back up. Gravity's pulling me down, but I don't get pulled down to the center of the earth because the normal force of the ground pushes me back up. Equal opposite. Overall, I don't move. The normal force of the table stops the laptop from moving. I can push even harder on this guy. The normal force gets even bigger. So a normal force, Fn, is equal to, in most cases, in Physics 105, it's equal to the opposite of gravity. If you have 10 newtons pulling you down, the normal force is 10 newtons pushing back up. 10 minus 10 equals 0. All opposite of downward force. So the frictional force is equal to some constant, some coefficient. Could be the coefficient of static friction or kinetic friction. This is a number they'll give you on the test. Times your normal force. Okay. One more thing you talked about was net or total force. Okay, I know Dr. Globe uses the word total, I believe. At least that's what my students have told me in the past. I don't know which word Dr. Holland uses. You guys? Yeah. Okay. They both mean the same thing. A net force or a total force is just equal to all the forces on a body. So if I say net, I mean total. If I say total, I mean net. F net is equal to F1 plus F2 plus F3 plus ya equals M times A. Okay. So right now, a question you might get asked, if a box has, if a 8-kilogram box has 20 newtons to the right and 4 newtons to the left, what is the acceleration okay. So this problem, we know we have a force of 20 newtons to the right. My arrow or vector is just telling us which way the force is. We also have a force of 4 newtons to the left. We want to find acceleration. So, thoughts and where to begin? So, what is our most basic equation that has acceleration in it? F equals ma. Well, we also know the mass is 8 kilograms. We know mass. We're looking for A. And we would need to know force. But this would just be the same thing as the net force. Can we find the net force? What makes you say 24? So I hear 24 is 16. So F net equals F1 plus F2. This is equal to 20 newtons to the right plus 4 newtons to the left. They're at opposite directions. They won't add together, they will subtract. Some of this 4 newtons goes against the 20 newtons, so we lose some. So I could just say this is positive 20 newtons plus negative, because it's left, 4 newtons. This becomes 16 newtons. So now F net equals ma, 16 newtons equals 8 kilograms times A. Let's say 2. What's the units? Yes. Like I said, I don't know what Dr. Holland would do, but from my experience from Dr. Gold, I've seen tests where 2 meters per second was the answer, but not 2 meters per second squared. So it's important to know the units in Dr. Gold's class. Hey, yes, I know you guys might think that's evil, but you have to put up with it. Just like you have to put up with his E, none of the above at every question. But you'll all get through it and never see a test from him again. Unless you have a buddy who takes the class that asks you for help. Okay. So, any questions on how we solve that question? Okay. So, we have 1 more hour to go. At this point, are there any questions or specific topics you want me to talk about the next hour? Yes?
Can I read this problem? It's from our last quiz.
Okay.
I don't know if you have already made it to you.
Yeah, can you bring it up here?
Yep.
Close one? Okay. So, okay. So, okay. So the question is a thermodynamics question or heat, depending when the teacher uses. Okay? So the question is 585 calories of heat is added to 1 gram of water of 55 degrees Celsius. What is the final temp of water gas? Okay, I have a feeling this is a Dr. Globe question. Okay, so we have 585 calories of heat is added to 1 grams of water at 55 degrees Celsius. Now, just so everyone's on the same page, I know Dr. Holland did heat. When he talked about heat, did he use units of joules or units of calories? What? Joules. Okay. So a calorie is also a unit of heat. Dr. Globe just does it in a different unit. The concept's the same. Okay? So what happens? We have a cup. And we have water in it at 55 degrees Celsius. We're going to dump a heat. Q means heat in physics. I don't know what your teachers use, but that's the standard. 85 calories into the water. And when you add heat to water, what happens to it? It's hotter. If you add enough heat, it might even boil. Okay. So we know how much heat we're adding. 585 calories. We know the mass. 1 gram. This temperature is our initial temperature. Ti is 55. What are we looking for? T final. Okay. So there's several things that can happen here. We have our water. It can start at some temperature, 55.